Okay, welcome everyone. Yes, I will be talking today about a relatively young programming language called Elm, and I'll start by showing it from three different perspectives, namely as a functional programming language, as a language for web programming, and as a reactive language, or a language that tries to put into practice the idea of functional reactive programming. So let's start. What kind of functional programming language is it? Elm is statically typed. It has a compiler that type checks the programs and compiles them to the standard web technologies, JavaScript, HTML, and CSS. It has a syntax that is similar to the syntax of Haskell, although there are differences. It is strict, meaning expressions are evaluated eagerly. And it has the basic features that you may expect from functional languages, such as it treats functions as values, or it provides immutable data structures. Let's see an example. And I will not be original. This is a function that calculates a list of Fibonacci numbers. It starts with a module declaration, which is strictly speaking optional in Elm programs, but most non-trivial programs will probably have it. Then we have an import statement. We are importing several functions from the standard library module called list. I will skip the module declarations and the import statements in most of the examples later. And then we have the function. It begins with a signature that is also optional, but I will be including signatures. And this signature tells us that the function is called fib, that it takes an integer number and it returns a list of integers. And then we have the function body, which consists of a let expression, which let us define local values or functions. In this case, I'm defining three local functions. The first one, called second, is a composition of the tail and head functions. The operator in between is one of the function composition operators, where in this case tail is executed first. This next function calculates the sum of the first two elements of a list, and you can maybe notice that function application is written as the function name and space and the argument with no additional interpunction. We have another function that is using the conditional expression. It's calling itself recursively. This operator is a cons operator. It prepends a value to a list, obviously returning a new list. And finally, after the in keywords, we have the result of the whole let expression. In this case, we are calling the fib apostrophe function, and then the result of that call is passed as argument to the reverse function. So this operator is a flipped function application operator. It evaluates the expression on the left and passes the result to the function on the right. All right, we have a function. We can test it in a rep. Elm provides a rep like many other languages. So here is an example session. We import a function, we execute it, and exit. That was a short example. Now let's move to the next perspective that I want to show. Elm is also a language for web programming. And this brings us to the Hello World example. So after the module declaration and the imports, we have just one function called main. The function main is the function that defines the meaning of Elm programs. In this case, the result type is called element. An element is a data type that basically represents something that can be rendered on the screen and that has defined dimensions. We create the element by using the plain text function that takes a string and returns an element. And once we compile this program, we get an HTML page that we can see in the browser. I also have the browser, I hope. Stopped working. Right, this is the hello world example. All right, the next example I will show will be drawing a few circles. So the result will look like this. And this one will be composed of several functions. The first function is called color. It takes a number and returns a color from a predefined list. It's basically using the number as an index to the list, modulo the length of the list. Next thing, I'm defining a type alias. So a tuple with an integer on the left, which will represent the radius, and the tuple on the right, which will represent the position of the center of the screen, is called, I give it an alias called circle description. And now I have a function that takes a circle description and returns a form, which is another data type from the standard library. In a moment, I will show how a list of forms will be transformed into an element. In this case, I'm creating the circular shape, then filling it with a color and moving it to the right position. Finally, I have a function that takes a list of circle descriptions and the dimensions of the element to be created as a tuple. And it's using the standard function collage, which takes the dimensions and a list of forms. And it gives us an element. And you may notice also how this is a function with two arguments. Like in Haskell, Elm uses the caret form. So it's strictly speaking a function of one argument that returns another function of an argument, and that the other function returns a value. But I will call it a two argument function. Here I'm using my function to giving it the descriptions of 4 circles. I'm also creating another element representing the square. Now I have 2 elements, but I need 1. There are several ways to combine them. What I need in this case is I put them like one in front of the other, and that's why I use the function layers. And that completes our program. I have only scratched the surface of web programming, but hopefully you can see that Elms provides a way to structure the code and compose your view from pieces, and you have the whole power of a functional language to kind of organize your code. All right, let's move to the reactive part, because our web page was static. Let's do something that will move. And when talking about the reactive part, I need to start talking about a notion of a signal, which is a very important notion in Elm. And informally, a signal is kind of like a value that changes through time. There are certain moments when the value may change of a signal, and then those moments can be detected and reacted to. So you can also view the signal as a stream of events that you react to and do something when they happen, or as a value that changes in time. An example of this is a signal that represents the mouse position. So the pointer, the mouse pointer can move, its position can change, so it's represented as a signal. The type of the mouse position is a signal of a tuple, where the tuple has 2 integer values. Such a value cannot be directly rendered on the screen. But what we can render, and that is what we can assign to main, is a signal of elements. So we need a way to transform a signal of integer tuples into a signal of elements. And there is a function for that called map. And the function that we are mapping is taking a value and turns the value into an element. The result of this program looks like this. All right. I'm moving the mouse and the position is changing, right? It's kind of reacting very slowly. Oh, okay. I have screenshots just in case, but yeah. Okay. Now another example. I have two signals here that represent the same information, mouse.x and mouse.y. How can I show two signals, not one? I have a function that combines two integers into an element using the plain text function. This operator is a function of $. So instead of putting the whole thing into parentheses, I can use this operator, and it will calculate the whole value of this expression and give it as an argument to the function. So I have a map2 function, I have a function of two arguments, and I have two signals. That way, both values from both signals are combined together and can be showed. Let's go back to kind of not working well. Okay. Basically, similar thing. I move the mouse and the position is updated. Also notice that the position, when I move the mouse towards the left upper corner, the position is that the coordinates are closer to 0, because the coordinate system is using the system that the origin is in the top left corner, and the coordinate grow to the right and to the bottom. I will change it in one of the examples later. Here is another version of this program. So instead of using the map2 function, I can use an operator that looks like this. This function is the same, this one. So I put a function of two arguments. I put this little arrow, the first signal, and the tilde, and another signal. If you know what applicative functors are and the applicative operations, these are those operations specialized to signals. I could put a function of 2, 3, 4 arguments and then put more signals here, just separating them with the tilde character. Okay, the result of this program is the same as the previous one. Now what I want to do is I want to change the coordinate system of the mouse. So instead of having origin in the top left corner, I want to have it in the center, and I want the coordinates to grow to the right and to the top. In order to do that, I need to know the dimensions of the screen, which are also changing, yeah? Right? Because I can change the size of the browser. So they are also represented as a signal. The signal is called window dimensions, and I can adjust. This is a calculation that adjusts the coordinates, and I'm using the function and the two signals. The result will be this one. So now when I'm in the middle or close to the middle, the coordinates are close to 0. When I go to the right and to the top, they will grow. All right, two more examples. Yeah, this is the main function where I use the mouse position signal and turn it into a signal of elements. I will now introduce time element. So I want to have a signal where the mouse position is delayed by an amount of time. The function to do it is this from the standard library. It's called delay. The unit that I use is 1/10 of the second, so 10 units will be 1 second. And I give a signal. I delay it by an amount, and I'm also adding the time information to the result. So instead of a signal of just a tuple, I get the signal of tuple with the delay and the actual position on the right-hand side. This is an anonymous function in Elm. So let's see. And then I make a program where I delay the mouse position by 1 second. So let's see. I will now move the mouse. So I'm moving the mouse, nothing happens, and then after 1 second, it's changed. I'm moving again. It changed after 1 second. All right, one more example with signals. Let me maybe show you first the result that I want to achieve. Now what I want to have this signal of mouse coordinates showed multiple times with different delays. So when I move the mouse, the first one will change immediately, the second one will change after a second, and the third one after 2.5 seconds. Let's see. How can this be done? So I do it in steps. First, I will take a signal. I will take a list of delays, and I will return a list of signals. I'm using a repeat operation just from the standard list operation, which takes a number and the value and returns a list with that value repeated several times. And then I use my previous function, mapping it through the list of delays. So I get a list of delayed signals. But what I want is not a list of signals. I want a signal with a list of delays inside. How do I do it? There is a well-known operation in functional programming, usually called sequence. This is its definition, specialized for lists and signals. The exact body is not maybe important. Just remember that it just takes a list of signals and returns a signal with a list inside. And you may know from other languages that this operation could be defined in terms of certain abstractions, such as applicative and traversable. This is not currently possible in Elm, because Elm does not have features that, like higher kind of types, that support such writing such general operators. It may be possible in the future. I don't exclude that, but it's not a promise. Just remember, I'm talking here on my own behalf, only not representing anyone, and certainly not the language creators, so I can only speculate. However, the language is still evolving. Features are added, so maybe new features will be added as well that will allow writing such more general operations. Now I need to take my previous function and combine it with a signal with a list of delays. And here, as an example, I use the 3 delays, 0, 10, and 25. So I was trying to show you Elm from the functional perspective as a web programming language and as a reactive language. But the power of Elm comes also from the fact that it's one language and you can combine all those features together. So let's see what happens when I combine the 3 examples before into one program. I have a program here that uses the draw circles function that I showed before. That function took a list of circle descriptions and was returning an element representing the circles. I have the fib function, which returns a list of Fibonacci numbers. And I have the delayed positions function, which takes a list of delays and returns a signal with those mouse positions delayed. Can you figure out what this program does? I will give you a moment to think, and then I will show you. Anyone can guess?
To move a circle ever faster?
Yeah, let's see. So I have my circles, and they are following the mouse. Kind of not working very smoothly for some reason.
Nice.
So I think it's nice that we can do this in a completely functional way. There's one more thing that I want to show. That is how we can maintain state in Elm programs. Let's go to presentation. Maybe I will show you the result that I want to achieve first. I have another program. Now I want to add one more feature. When I click, the screen will freeze. The program remembers the current positions. When I click again, the circles move again. So in order to do that, I will need to maintain state. I will need to remember whether we are in the frozen or unfrozen state. And I will need to remember the current position of the circles. So how can I do that? First, let's represent the state. I'm using a record type here, and I'm giving it an alias. So my type is called state. It has two values. The frozen is a flag that remembers whether we are in the frozen or unfrozen state. And the circles is a list of those circle descriptions. I didn't use the alias here. That remembers the current position of the circles. I will need the initial state. So this is a function that creates the initial state. I don't need to create the circles. I will get them immediately from the mouse positions. I will also need two different sources, independent sources of input. So one of them is the mouse positions that are delayed but still kind of coming from the position of the mouse. And the other one is the sequence of mouse clicks that I need to handle. They're kind of independent. So let's create a data type to represent those two types of input. This is a union type. It has two alternatives. The click value represents an event of clicking the mouse, and the circles represents our positions of the circles. I will now need to transform the input signals into a signal of events. This signal, mouse clicks, is a signal from the standard library. It's actually a signal that has always the same value, unit, but it has those moments in time that can be detected and reacted to. I'm changing it to a signal of clicks, but by using a constant function. So always is a function that takes a value and returns a function. That is a function that takes any value and returns click always. And I'm mapping that function over the signal. I get a signal of clicks. So this signal will always have the same value, click, but we will be able to detect the events. The other signal is the signal that I used before. I'm only wrapping it in the circles type constructor. I have now two signals of events. I can simply merge them, and I get a signal of events that have kind of represent those two sources of data, of input data. So I have my state, I have the input, the signal of input event. I will now need a function that will take the next or the incoming event, take the current state, and will produce the next state. I call this function step. It takes an event, a state, and returns the new state. I'm using the case function, and I'm pattern matching on the frozen flag and the incoming event. I need to handle three cases here. The first case is when there is a mouse click. So when there is a mouse click, I want to negate the state from frozen to unfrozen or vice versa. This is the syntax to take a record and update one of the fields of this record with a new value. This is obviously, this underscore obviously means that I don't care about the value. The second situation that I want to handle is when we are in unfrozen state. In this case, I want to take the new positions and I want to update the state with the new positions. And finally, the third situation is when we are in the frozen state, I won't just do nothing. Yeah? I want to ignore the incoming, the new position, forget about it, because I remember the position that I remembered before. So now I have three elements that I need to combine. I have the state. I have a kind of a representation of my state. I have a signal of input events. And I have a function that is taking the current event and the current state and returns the new state. The one missing piece is the fault p function, which should be interpreted as fault from the past. And it takes three arguments. The step function, that is combining the event and the state and producing the new state. The initial state to start with, and the signal of events. What it returns is a signal of states. And now there is one missing piece that I need to do. From a signal of states, I want to extract. Actually, from the state, I want to extract one of the members. So from the signal of states, I want to get a signal of circle positions. I do it by mapping a function that is called dot and the member name. So every record type in Elm has kind of built in a function that is called dot and the name of the member. And the function is just taking the record and extracting the value from returning the value of the member, of the record member. So by using this, I get a signal of list of circle descriptions. This is the complete program. Instead of using the signal that I had before, I'm using the new signal. The rest is the same. All right, that was actually the last example. If you want to know more, this is the website, the official website of the Elm language. I have also written a tutorial, and it's on the internet. It's available here, and this address, I will probably be updating it. And that's it. I can take now questions.
Yeah. I have one question. We have an Elm code. We compile it. How does it go in HTML file? Is that HTML or Elm code or something else?
Let me show you. How can I see the source here? Do you know the Safari? Where is the option to see the source?
You need to go to preferences, and there is something like enable programming menu, something like that.
Maybe.
Safari. Yes, and settings, preferences, and in advanced, it's the last one. Yes, here, and on the bottom, show develop menu in the bar.
They make it difficult.
And now you have on the top of the menu, you have to develop, and here, show yourselves. Yeah.
Great.
Basically, it's mainly JavaScript. There is just a wrapper. Actually, when you compile Elm code, I have given an option to generate an HTML file. I could skip this option and I could just get a JavaScript file. You can also take this JavaScript code and instead of embedding it kind of as the whole page, you can make an application traditionally in HTML. You can have a div, for example, and put your Elm code, your Elm program in this div. So the answer is it's mainly JavaScript in this case.
So is this using Canvas or separate elements?
I think but actually I told you about elements. There are actually 4 data types that can be returned as or assigned as the return type of main. An element, and the second type that is recently was added as an option is called HTML. So you can also kind of structure your code using this syntax, but in kind of HTML way. I didn't really take a look at this, so I don't know exactly. And the 2 other options are signals of elements and signals of HTML. As far as I know, the HTML is using something called Virtual DOM, a library, I think. And I'm not really I don't know exactly the answer, to be honest, because I'm not looking at kind of under the hood how it's done. The point is also that this can change because it's an implementation detail from the point of view of you as a programmer writing Elm. So you can write the program and wait for a new release. Maybe it will be implemented differently and will work faster. Yes?
Can I use it to do some Ajax calls to the server?
Yes, I think people are using it. There is also a way of interfacing with JavaScript. So you can also write your JavaScript and kind of interface with Elm. And I think people are using it for writing Ajax call. I don't think I have tried, so yeah. Yes?
So you said you can have a HTML template and put your Elm part of the application inside of it.
Mm-hmm.
Can you do the other way around? So you can have, for example, a blog HTML and, for example, you want to animate this whole blog around the page. Can you do that?
I'm not sure. I know you can use Markdown as a kind of. There's this syntax called Markdown, which can be transformed into HTML, and this syntax is supported in Elm programs, so you can use this. I'm not sure if you could embed just plain HTML syntax with the braces.
Something inside your Elm code can be used to have some like classic website things.
I don't know a way to do this, to be honest.
So I think if you can interoperate with JavaScript, then you can do all the codes that normally have been made for.
Yes?
I was just wondering if you've had any comparison between this and, say, something like PureScript?
So PureScript, I don't know it very well, but I would say as a short answer, I would say that I showed you these three perspectives, functional, web, and reactive. I would say that PureScript is doing the functional part maybe better because it focuses on this part only, so it has those more advanced language features. Elm is maybe less advanced in the basic language function facilities, like those higher kind types. It doesn't have type classes like PureScript, right? I think PureScript has type classes, right? Yeah. If I'm so Elm doesn't have it, but Elm has those other things. I think there was someone writing a signal library for PureScript, which was based or inspired by the signals in Elm.
So I'm teaching Elixir to youngsters, as I yabbered about this morning. So when they've learned Elixir, I'd like to do something with the UI. Would Elm be suitable for 13 to 14-year-old to get into once they've learned Elixir? Is that a good way to do a UI, or should I do something else?
I'm not sure I understand. The question is whether Elm is good for teaching UI, right?
Yeah, so at the point where they turn to Elm, they've already learned Elixir, so they know functional programming, all the wonders of Elixir. Yeah. So at that one point you need to have a UI.
Yeah.
So is Elm a good step after that, or?
In my opinion, yes. Obviously, it's an opinion, and it gives you it's using a certain paradigm, the functional reactive programming paradigm. So it's different from the traditional way of building pages. So it depends on what you want to teach them. But in general, as a way of teaching programming and functional programming, I think it's great because you can easily show something and see the result of what you are doing. Right?
Any more questions?
Just one more thing that I may add. Remember that this is a language that is being developed. It didn't reach the version 1.0. Breaking changes are happening. So if you want to use it, you will be a pioneer more than it's definitely not yet a mainstream language, right?